Good day, I'm Belgio Villatero together with my partner Adrian Manukan. We are students taking up Bachelor in Secondary Education, major in Mathematics. So today we'll discuss mathematical induction using this given statement. We have 3 plus 7 plus 11 plus ellipsis plus the quantity of 4n minus 1 is equal to n times the quantity of 2n plus 1 for all n is greater than or equal to 1. Now we'll use the principle of induction to establish the formula. First step would be to the basis verify for n is equal to 1. First, we need to get the last term and its equal term, which is 4n minus 1 is it equal to n times 2n plus 1. Next step, we'll substitute 1 to all n. We'll have 4 times 1 minus 1 is it equal to 1 times the quantity of 2 times 1 plus 1. And then by simplifying, we'll have 4 minus 1 is equal to 1 times 2 plus 1. Then we subtract 1 from 4, we'll have 3, and we added 1 to 2, we'll have 3. Therefore, we'll have 3 is it equal to 1 times 3. And then by simplifying, we'll have 3 is equal to 3. Hence, the formula holds true for n is equal to 1. Now, the next step would be to assume that the formula holds for some arbitrary n is equal to k such that 3 plus 7 plus 11 plus ellipsis plus the quantity of 4n minus 1 is equal to n times the quantity of 2n plus 1. So now we'll have this statement, the mathematical statement, 3 plus 7 plus 11 plus ellipsis plus quantity of 4k minus 1 is equal to k times 2k plus 1. What we did is we only substitute k to all n. Now to show what we need to prove, we have 3 plus 7 plus 11 plus ellipsis plus quantity of 4k minus 1 is equal to k times the quantity of 2k plus 1. Now we add 4k plus 1 minus 1. What we did is we added k plus 1 to the given, or we let k is equal to k plus 1 because from our given it states that for all n is greater than or equal to 1. From our first step, we only verified n is equal to 1. Now we have to verify n is greater than 1. Same as to the right hand, we let k is equal to k plus 1. So now we'll have 3 plus 7 plus 11 plus ellipsis times plus the quantity of 4k plus 1 plus 4 times the quantity of k plus 1 minus 1 is equal to k plus 1 times 2 quantity of k plus 1 plus 1. Now we have manipulate the right hand. So by simplifying, we have to distribute 2 to k plus 1, we'll have 2k plus 2. Then we'll simplify, we add 1 to 2, we'll have 2k plus 3. Then we'll get k plus 1 times 2k plus 3. By FOIL method, we expand the binomial expressions, which are k plus 1, 2k plus 3. We'll have 2k squared plus 3k plus 2k plus 3. By adding the common terms, which are 3k plus 2k, we'll have 2k squared plus 5k plus 3. Now that's what we need to prove. 2k squared plus 5k plus 3.
Now we have the mathematical statement 3 plus 7 plus 11 plus ellipsis plus the quantity of 4k minus 1 plus the quantity of 4 times the quantity of k plus 1 minus 1 is equal to k times the quantity of 2k plus 1. You notice that on the left hand of our statement, we added the 4 times the quantity k plus 1 minus 1. Therefore, what we need to do is to add this quantity to the right hand. So now we have the statement 3 plus 7 plus 11 plus ellipsis plus the quantity of 4k minus 1 plus the quantity of 4 times the quantity k plus 1 minus 1 is equal k times the quantity 2k plus 1 plus the quantity 4 times the quantity k plus 1 minus 1. For this, we only manipulate the right hand of the statement. And by simplification, the statement on the right hand, you notice that k times the quantity 2k minus 1 can be simplified using distribution property. We distribute k to the quantity 2k plus 1 and it will give us 2k squared plus k. And also, to the last part of the equation, it can be also simplified by distribution, which 4 times the quantity k plus 1 can be simplified as 4k plus 4. And for our statement on the right hand, it becomes 2k squared plus k plus the quantity 4k plus 4 minus 1. This equation can be simplified as well. You notice that the last portion of our equation, 4k plus 4 minus 1, can be simplified by adding negative 1 to the 4, and it will give us 4k plus 3. And now we have equation on the right hand, 2k squared plus k plus the quantity 4k plus 3. This equation can be written as 2k squared plus k plus 4k plus 3. And then for our next step, we tend to add the common terms, which are k and 4k. So now our equation will be turned into 2k squared plus 5k plus 3. And this one is now the expanded form. And go back to what we need to prove that discussed or explained by Ms. Lotero a while ago. We see that the two possess the same expanded form. So these two are equal. Then let's proceed to the conclusion of our proving. Hence, the formula holds true for n is equal k plus 1. Therefore, by principle of induction, the formula is true for any positive integer n.
We hope that this video enlightened you in understanding mathematical induction. Thank you!